Well, dear students, in our last session, we started discussing about what is called electric potential. We have defined what is electric potential mathematically, and also we have tried to understand what is the significance of electric potential. We also derived the formula for electric potential due to a point charge. And in today's session, we will continue with this discussion. First, I will write the formula which we derived in the last class, and also mathematical form of electric potential. Remember, mathematically electric potential V is equal to work done by charge. This is basic formula, as we all know. Potential is equal to work done by charge. In fact, it is the work done to move a charge from infinity to given point in an electric field and against it. Accordingly, we wrote this is 1 joule by 1 coulomb, which is nothing but 1 volt is SI unit. Remember, we also derived the formula for electric potential due to a charge according to the arrangement. If Q is the charge, and if you want to know what is the potential at this point P, distance R from the charge, the formula for this arrangement is V is equal to 1 by 4 pi E naught into Q divided by R. This is the expression we arrived at. This is the expression we arrived at. Remember. And it is done by means of work done in bringing a charge from infinity to given point against electric field. Against electric field, what is brought? Q naught, which is plus 1 coulomb. Remember, students, if it is a positive charge, potential becomes positive. Remember, if suppose this is a negative charge, potential due to negative charge, we have to write with the minus sign. Due to negative charge, remember this is positive charge. Due to negative charge, the formula becomes minus Q by R at the same time. So accordingly, students, potential due to positive charge is positive potential. Potential due to negative charge is negative potential. And you remember, potential at infinity due to a charge is always 0. Potential due to a charge or potential of a charge at infinity 0 means, in fact, in this expression we have considered the charge is being moved from a point of 0 potential to a point of certain finite potential. If you want to move from a point of 0 potential to a certain finite potential, it is as same as lifting water from a 0 level or from a ground level to certain higher level. What is to be done? Work is to be done. In order to lift water from the ground level, say that is what we call 0 level, to a certain height above, higher level, higher potential, lower level, higher level. That is why I mentioned very clearly in the last class that potential is analog to level or height, and it is also analog to what is called temperature of a body. Generally, you remember, heat flows from a body at higher temperature to a body at lower temperature. However, if you want to make the heat to flow from low temperature to high temperature, what should be done? Work should be done. This is what we observe in case of refrigerators. In fact, we have studied the second law of thermodynamics in the first PU course. Understand? Means to make the heat to flow from low temperature to high temperature, we need to do work. Heat to flow from high temperature to lower temperature, it moves on its own. It flows on its own. Similarly, I remind you once again, remember, electric potential is as similar to level, or you can say height, level or height, as far as gravitational force is as similar to temperature of a body. Yes. Well, so if you compare the terms potential with the level or height and with the temperature, it is easy for you to analyze. Remember, in order to move a charge from zero potential to some finite potential, what should be done? And a charge flows on its own from a certain higher potential to lower potential. Positive charges moves from higher potential to lower potential on its own. Well, we'll continue. Remember, similarly, potential difference, electric potential difference, this in term is also, in short, can be called PD. PD means potential difference. In fact, we will be using the term potential difference in brief as PD. Remember, electric potential difference. It is the difference between potential at given 2 points. Or let us consider positive charge plus Q, and if you want to know, this is point A, remember, this is another point B, remember, then A is at a distance say R1, B is at a distance say R2 from the source charge, like this. Then what is the potential difference? In fact, as we know, potential at A would be large because the near point, potential at B would be less because far point. Therefore, potential difference VA minus VB, we have to write. This is called potential difference. Higher potential minus lower. This is also measured or calculated with the same definition, like it is the work done in moving a unit positive charge from one point to another point in an electric field against it, as written in the last class. So here we are moving the charge Q naught against the electric field. Remember, this is how we have to refer. And how it is calculated? What is potential at A? With respect to this formula, 1 by 4 pi E naught Q divided by R1 minus 1 by 4 pi E naught Q divided by R2. What is common, you remember? VA minus VB is equal to Q by 4 pi E naught into 1 by R1 minus 1 by R2. This is the formula for potential difference between 2 points due to a charge, due to a point charge. Only potential, one fixed point. What is other point? Of course, infinity. Students, remember, it is even same as, this is even same as potential difference between infinity and a point B. And you know, potential at infinity is 0, and so only we are left with this part. Anyhow, you remember what is only potential at a point? Then this is the formula. Potential difference between 2 points, here is the formula. Here is the formula. You have to note down these points. So this is the formula written, derived in the last class. You can notice them, and you always remember electric potential, level of water or position, height, you can say temperature. These are all the analog terms. These are all analog terms. Well, students, you should also remember positive potential is higher potential. Positive potential is higher potential. And the negative potential is a lower potential. Negative potential is lower potential, remember always. And you remember positive charges, maybe positive unit charges moves from higher potential to lower potential always on their own, easily they can. Negative charges moves from lower potential to higher potential on their own. As we mentioned in the last class, potential is a scalar quantity. Hence, it can be positive, negative, or even can be zero. Remember, positive charges can move freely on their own from higher potential to lower potential. However, if you want to move a positive charge from lower potential to higher potential, work should be done. Like for example, here we are moving positive charge from infinity, that is lower potential, to higher potential. Work is done. Negative charges can move on their own from lower potential to higher potential. I repeat once again, potential similar to level. Positive charges move from higher potential to lower potential on their own. Water flows from higher level to lower level on its own. Heat flows from higher temperature to lower temperature on its own. Like that. Positive charges cannot move from lower potential to higher potential on their own, for which work should be done. Water or any liquid cannot flow from low level to higher level, lower level to higher level on its own. Hence, we are using motors to lift water from ground level to underground level to overhead tank in our houses. You remember. Heat also cannot flow on its own from a body at lower temperature to a body at higher temperature. In order to do so, you need motors. This is the principle of the second law of thermodynamics, where refrigerators and air conditioners do work on the similar principle. I am saying why, because electric potential is a similar such entity or the physical quantity like level or height and like temperature. Level and height regarded for the flow of liquid, maybe temperature for the flow of heat. Well, with this understanding, let us now write what is the electric potential at a point due to number of charges. What should be done? It is algebraic sum of potentials due to individual charges, because potential is a scalar quantity. Therefore, net potential, total potential, algebraic sum of potentials due to individual charges. Let us take the arrangement. I write what is potential due to number of charges. Here I write electric potential, due to number of charges, like earlier we calculated what is electric field intensity due to number of charges. We applied superposition principle, even electric force to calculate due to number of charges, and electric field and electric force are being vectors, so we applied vector sum. Here potential is a scalar quantity, so we apply algebraic sum. Rather we can say superposition principle we are applying. Well, let us consider an arrangement. Here is a point P, assume a point P. There is one charge here, say Q1 I take, distance R1, this is point P, remember. There is another charge here, Q2, distance R2, another charge Q3, distance R3, Q4, distance R4, and so on. And we would like to find the potential at this point P. Potential at this point P due to Q1, Q2, Q3, Q4. Therefore, total potential at P is equal to potential due to charge 1 plus potential due to charge 2 plus potential due to charge 3 plus potential due to charge 4, since there are 4 charges. What kind of sum it is? It is algebraic sum or scalar sum, you can say. Of course, this is also based on superposition principle, we can say. And you know what is the formula for potential at P due to charge Q1, which we named V1, which is 1 by 4 pi E naught Q1 by R1. There may be negative charges also. If there is a negative charge, you write negative potential. Suppose if I put Q3 as negative, assume Q3 as negative, then while writing V3, you should account the sign of Q3, that's all. I write here Vp. Vp refers to what? Potential at P. Formula 1 by 4 pi E naught. Remember, it is common for all the potentials. It is common. What is this? First case Q1 by R1 plus second Q2 by R2. Remember, third is negative, therefore minus Q3 by R3 plus positive again Q4 by R4. This is how we write. This is how we write. If there is positive charge, positive potential, negative charge, negative potential. This is general formula. You can sum up. And in general, we can write for n number of charges. For n number of charges, in general, we can write potential due to number of charges at the same point can be written as summation of, this is common. I think we can write like this easily. You are all familiar with respect to this. where I is equal to 1 to n. Qi by Ri, remember? One to n. 1 by 4 pi naught is being constant. It is not variable. Charges are variables. So the charge values are different. Distances are different. Therefore, Qi by Ri, where I takes value from 1 to n. Algebraic sum, summation it is. And you also remember potential due to a charge depends on nature of surrounding medium. What kind of medium surrounds the charge while measuring potential at a point in a field? You remember we measure potential in an electric field surrounding the charge. Potential is calculated at a point in an electric field. Students, you have to note down all these points carefully. These are all the mathematical steps. You have to note. Hence, I am going very slowly and gradually. So, please note down what all the terms, formulas written on the board. Hope that this is visible. Well, hope that you have noticed all the terms and the formulas written on the board. Now, let us proceed further to learn few more aspects on electric potential. I clear this part on the board. Well, students, you should also remember that electric potential depends on the medium surrounding. In all these cases, we have considered the surrounding medium is air or vacuum. Hence, the term epsilon naught or E naught, that is absolute permittivity. V in air or vacuum. Right. V in air or vacuum. Now, V in a medium. In a medium means other than air or vacuum. Other than air or vacuum. E, absolute permittivity of a medium other than air or vacuum. Other than air or vacuum. And we know that E is equal to E naught into ER, as we know. This is known. Therefore, we can substitute this V in a medium. V, potential of a charge in a medium other than air or vacuum. We can quote like this. Yes. ER, as you know, ER is relative permittivity. What is the other name? Dielectric constant. The other name is dielectric constant. Now, this part, except ER, this is V in air. Therefore, V in a medium is equal to V in air divided by ER. Athwa V in air divided by K. What is K? Dielectric constant. So, this is how the relation you find. Means in the presence of a dielectric medium which is other than air. Of course, air is also a dielectric. For air, the value of dielectric constant is 1. and for all other media it is greater than 1, as you know, and for metals you know this is infinity, this dielectric constant. Therefore, potential due to a charge in air or vacuum and potential due to same charge under the same distance in a medium other than air or vacuum, when you measure, definitely potential in a medium decreases. I write V in a medium, potential in a medium would be lesser than potential measured in air or vacuum always. Why? Because this value for a medium other than air or vacuum is greater than 1. Like as usual, electric field decreases in a dielectric medium, electric force decreases in a dielectric medium, electric potential also decreases in a dielectric medium other than air or vacuum. Why? Because air is also a dielectric, and you know what are dielectrics, that part we have learnt in brief. Well students, now with this discussion, now we are going to derive another important formula in this chapter, that is we are going to establish what would be the electric potential due to a dipole. You know what is a dipole? Electric dipole, a system of two equal and opposite charges separated by some distance. That is called electric dipole, and molecules having this property is called polar molecules. Polar molecules, and those do not have this property, they are called non-polar molecules. Well, now we are going to derive a formula for electric potential due to dipole. Another important 5 marks question. Hope that you have noticed these points, how potential varies with medium, it is noticed. Now let us proceed to get the formula, to get the expression for potential due to dipole. Well students, now we are going to write the expression, and we are going to prepare the expression for potential due to dipole. Here is the arrangement I have drawn. You know, you are very much familiar with electric dipole. A system of two equal and opposite charges separated by some distance. Look at this, minus q and plus q. Minus q at A, plus q at B. A is the distance from center of the dipole to this charge at A, and this is also distance A. Now our aim is to find electric potential at point P. At point P, distance r from the center of the dipole. What is center of the dipole? O is the center of the dipole. O is a point on the axial line of dipole at equal distance from either of the charge. Well, P is the point, distance r. Now what is potential at P due to charge at A? Potential at P due to charge at B, and we know we go with the algebraic sum of potentials. The distance of the point P from charge minus q is AP, which is unknown. Similarly, this distance is also not known. In order to find these distances, we have made additional construction which is already drawn here. See that. So what is done? AM is the perpendicular drawn on the PO produced. AM is the perpendicular drawn on the PO produced, remember. Similarly, BN, or NB is the perpendicular drawn to PO. Perpendicular drawn, and remember carefully that dipole always we choose short dipole. Therefore, AP is almost equal to PM, this distance and this, because they are very close. If dipole is short, this point, this A and M will be very close. Therefore, this distance is same. Similarly, also we consider this distance. I mean, PB and PN are equal distances. This is under the consideration that length of the dipole is very short. These are the additional construction made. I repeat once, charge minus q at A, charge plus q at B, separated by distance 2a, a plus a, 2a, and 2a is the length of the dipole. What is our aim? To find potential at P, distance r from the center of the dipole. And you remember this angle NOB is theta, and this is angle AOM is also theta. Why? Because these two are vertically opposite angles. Vertically opposite angles. This is theta as well as this is theta. Now, construction made, AM is the perpendicular drawn to the PO produced. AM is the perpendicular drawn to the PO produced. So, PN to the PO, another perpendicular, NB is drawn. This is additional construction made. What for? Simply because we know the potential due to a charge, say due to charge minus q, then we have to write the formula 1 by 4 pi naught minus q by this distance, what is AP. But this distance is not definitely known. This is an arbitrary distance. Let us replace it with the known data. What is known? Like A is known, theta is known. Similarly, PB is also an arbitrary distance. Replace it with known data. What is known? What is known? Theta is known and A is known. Henceforth. Well, shall we proceed now to follow the mathematical steps to arrive at the expression? So, what we have to consider initially? Consider a dipole. And consider dipole having charge minus q and plus 2, of course. And let P be the point at distance r from the center of the dipole. Then what you should write? AM is the perpendicular drawn to the PO produced. NB is the perpendicular drawn to the PB, to the PO produced. PO. Vertically opposite angles. Vertically opposite angles. NOB is equal to AOM. Remember, NOB is equal to AOM. Remember, since we have to write first now the potential at P due to charge at A, right? Charge at B first, right? That is VB 1 by 4 pi E naught. This is being positive, hence I write first. That's all. This distance PB. So BP. Similarly, potential at P due to charge at A, VA, of course at A negative charge, Q divided by, with minus sign, remember, what is the distance? AP. Therefore, now total potential at P is equal to VA plus VB. Which is equal to 1 by 4 pi E naught is common. Here Q by BP for VB minus Q by AP for VA. Remember, I write this one first. Q by Q is being common. 1 by, I take positive term first, BP minus 1 by AP. Now, important is what is BP and what is AP, we have to find. What would be AP distance and what would be BP distance, we have to find. That is our next discussion, because those are that is not known data, that is arbitrary distance. Replace BP and AP, those are distances from the respective charges. Here VA plus VB is there, but I have written the formula for VB first, because this is being positive, remember, this is negative. Now, how to write BP and AP in terms of known data, that is important now. In terms of known data, that is a very important part. Here we go with here I draw the line here. Now look at this spot. Here I am going to write BP. Remember, since dipole is being very short, this distance PA is almost equal to PM. So AP is almost equal to MP. And you know what is MP? MP is equal to MO plus OP, right? MP, M to P is equal to MO plus OP. And what is MO? We have to find, because OP is known. OP is R. Remember, OP is R. MO we have to find. And MO we can calculate in the triangle AOM, it's a right angle triangle. We want this distance, which is being adjacent side. So cos theta is equal to MO by OA. For right angled triangle AOM, cos theta is equal to MO divided by, remember, OA, which is equal to MO divided by OA is a small a, therefore MO is equal to, remember, A cos theta is the formula. Therefore, what you find? AP, which is as same as MP, which is equal to MO, A cos theta plus R, to R plus A cos theta. We can replace A cos theta plus R to R plus A cos theta. Similarly, BP you can write BP is equal to NP and NP can be written as PO minus ON. And PO is R minus ON. To know PO, similarly for right angled triangle, another right angled triangle, what is that? ONB or NOB. So BON. You write cos theta again, it will be ON by OB, which is ON by OB is again A, remember. OB is again A, remember. Therefore, ON is equal to A cos theta. Therefore, BP is equal to NP is equal to POR minus A cos theta. So, here R plus A cos theta, here R minus A cos theta. Now, we are in a position to substitute them in this equation. So, you will get final result. Call this as equation 1, substituting those terms in equation 1. That is the rest of the calculation. You can note down all the steps written. These are the steps you are supposed to follow with the necessary diagram. And remember, this can also be one important question for 5 marks, asking you to derive the expression for electric potential due to dipole. Then this is the diagram. These are all the steps necessary to calculate. And remember, students, so our aim is very importantly here, up to here we know very well. We know the formula for potential, how to write due to a charge. Here we have come across the unknown distance. So that is converted into known. For that, AP calculated. If can directly write, similarly we can calculate BP as R minus A cos theta. Directly you can show if necessary. R plus A cos theta. A cos theta plus R is same as R plus A cos theta. R plus A cos theta, same as A cos theta plus R. So, AP is found, BP is found. The rest of the calculation is just substituting this AP and BP in equation 1 and simplifying. You will get the required result. You can simplify and write in some proper order electric potential due to dipole you will get. Remember, PA, so AP is same as MP and MP is written as MO plus OP. MO plus OP. Similarly, PB and NP are similar distances. So, hence NP is written as PO minus ON. PO minus PO ON NP ಬರ್ತದೆ. Well, if written up to here, I clear this part and taking those values of AP and BP in equation 1 and we will write the final result. Now, therefore, equation 1 becomes, what is equation 1? Vp is equal to, look at this equation 1, Q by 4 pi E naught into bracket, 1 by bp, here it is 1 divided by, yes, r minus a cos theta minus ಮತ್ತೆ 1 divided by what is ap, r plus a cos theta, a cos theta plus r ಅಥವಾ r plus a cos theta, remember. Just you can also continue the calculation. This is a mathematical part now. Simplifying further. Now r minus a cos theta into r plus a cos theta. It is of the form a minus b into a plus b. And you know a minus b into a plus b is a square minus b square. That would be the LCM, r square minus a square cos square theta. Hope you understand this simplification part easily. Hope you understand this simplification part easily. So straight away I write, so a minus b, a plus b, a square minus b square, using that formula, r square minus a square cos square theta. Remember, this would be the LCM, r minus a cos theta into r plus a cos theta. In the first part you will be left with r plus a cos theta minus, in the second part you will be left with r minus a cos theta. So minus r minus theta minus plus a cos theta. I hope you understand this. This is very simple. Taking LCM, which is in the form a minus b into a plus b, a square minus b square, and writing the terms in the each part. Now you can see very clearly, plus r minus r cancel, plus r minus r cancel. You will be left with a cos theta plus a cos theta, 2a cos theta. I write here Vp is equal to q by 4 pi a naught into a cos theta a plus a cos theta 2a cos theta divided by r square minus a square cos square theta, because this part and this part cancel. This is the most generalized formula, and you remember q into 2a, charge into length of the dipole, either of the charge into length of the dipole. It is called, yes, electric dipole moment. Electric dipole moment. Electric dipole moment. So we can replace q into 2a is equal to p. What is p? Electric dipole moment. And of course, it is the product of either of the charge into length of the dipole. Product of either of the charge into length of the dipole. Product of either and magnitude of the charge and length or distance between the charges. So I write p cos theta divided by 4 pi e naught into r square minus a square cos square theta. This is the final result. P cos theta divided by 4 pi e naught r square minus a square cos square theta. And remember, theta value varies. This is easily you can analyze. If a point P lies on the axis of the dipole, then theta becomes 0 degree, then cos 0 becomes 1, then we will be left with just 1 by 4 pi naught P divided by r square minus a square cos square theta. Well, students, this is a formula for electric potential due to dipole. Remember, in the next session, we will discuss this result. We will take this formula and account for number of cases. And this is the most generalized formula. You know, theta is here. Theta is the angle between line joining from the observation point to axis of the dipole. Line joining from the observation point to the axis of the dipole. This is how. And we will continue our discussion with this result. Okay. Thank you.